A majority of utilities that use membranes are using the type that are pressure-driven. Pressure-driven membranes include microfiltration, ultrafiltration, nanofiltration, and reverse osmosis. Microfiltration, or MF, and ultrafiltration, UF, are sieving processes, which means they have pores that act like strainers. As water is forced through the membrane, under pressure, contaminants too large to fit through the pores are held back or rejected. MF and UF are pressure-driven membranes that operate between about 10 to 50 psi. MF and UF are a form of filtration similar to granular filtration in that they are used for particle removal. They turn typical surface water into potable water in the same way traditional treatment does through coagulation, flocculation, sedimentation, and filtration. Microfiltration membranes typically have a nominal pore size of about 0.1 microns. Those pores remove suspended matter, bacteria, turbidity, algae, fungi, and protozoa such as Giardia and Cryptosporidium. Microfiltration membranes are not effective for the removal of viruses or disinfection byproduct precursors. They are also not able to remove natural organic matter without the use of coagulation upstream. Ultrafiltration membranes typically have a nominal pore size of 0.01 microns, 10 times smaller than microfiltration pores. In addition to the same capabilities as MF, UF membranes can also remove viruses. MF and UF have been shown to be incredibly effective for removing particles in water, typically producing water with turbidity levels below 0.05 NTU. However, they do not remove inorganic chemicals such as chlorides or nitrates, nor do they remove metals or other ionic materials. To meet that challenge, some utilities are using semi-permeable desalination membranes, nanofiltration, and reverse osmosis processes. These membranes don't have pores. Instead, the water diffuses across the molecular structure of the membranes. Most molecules of suspended or dissolved substances can't pass through the membrane. These processes are more powerful but more expensive to operate. They require more pre-treatment and higher operating pressures. Nanofiltration, or NF, operates between 75 and 250 psi, and reverse osmosis, or RO, can require operating pressures as high as 1200 psi. Nanofiltration was originally developed as an alternative water softening treatment process. Like traditional lime softening, NF reduces the level of calcium and magnesium in hard waters. It is also more effective than lime at removing color. Nanofiltration will reject or remove most natural organic matter, DBP precursors, and microorganisms. NF has even been used to remove organic compounds such as pesticides. The other type of diffusion-controlled membrane process is reverse osmosis, or RO. RO was first used on municipal water supplies in the 1960s as a method of removing salts from brackish water. In recent years, RO systems have become more efficient and less expensive. And as water quality regulations tighten, reverse osmosis is becoming more popular for water treatment. RO can remove more contaminants than any of the other membrane processes. It is so effective, the US EPA endorses it as the best available method for removing inorganic chemicals from water. RO is used in agricultural areas to treat ground and surface waters contaminated with nitrates. RO is also one of the only technologies to economically remove salts from water. As a result, an increasing number of utilities are using RO to tap previously unusable water sources. Some facilities are even using reverse osmosis for reuse applications.